Hey Continental family, it's Jeff Schmidt. I'm here in Tidbinbilla, Australia, which is about a 45-minute drive from where we're staying in Canberra, Australia, which is the capital of Australia. We're here at DSS43. We just finished the upgrade of the new S-band and X-band transmitter. Everybody here at site is very pleased with all the work that's been performed. The site here has been very good to us, very awesome, providing us with everything we needed to get the job done in time. Ed, the director here at the station, has expressed his appreciation for all the hard work that Continental has done back home and the work that we've done here. So everyone here is extremely happy. This is very impromptu. It is almost 5 o'clock. It's Friday. We leave tomorrow to come back home. We're looking forward to coming back home and seeing you guys. But I just want to let you guys see the antenna, and then we're going to go through the different levels real quick while we have some time. So just to show you, here's the antenna. Here's our customer. Everybody knows Roland. He's a little giddy. He's very happy. So this is DSS43. The top of the antenna is 70 meters in diameter, which is about 230 feet. The base of the antenna, which we call the pedestal, is about 80 feet in diameter. We're going to walk through this pretty quick. We're going to walk into the pedestal room where the power supply is and the master controller, so y'all can see that. I'll show y'all the countryside. It's very beautiful out here. The weather has been really good this week. It's beginning to be spring. First 2 weeks that me and Carlos were here, it was horrible, but we got the job done. It was like 30 degrees Fahrenheit. Roland's shivering right now just thinking about it. 50-mile-an-hour winds and rain, but this week's been very good. So we're going to walk into the pedestal room real quick so you guys can see it. So you can see here we got the master transmitter controller, as we call it, sometimes called the pedestal controller. We have the schematic here on the wall so that we would have a quick reference to what needed to be done. We have the power supply here, which was put together the first 2 weeks that we were here. Just to show you guys how good everything's going, I'll turn this to local, turn beam on here. So everything here is working just like it did at the factory. We even had a little bit of time to fine-tune some things and make them even happier. So I'm gonna make my way up the antenna. Again, it's about 15 stories to get up. So there's going to be some places here where I have to put the camera in my pocket to climb. Hopefully this doesn't make you guys sick climbing the ladder while y'all are watching. I got to do this pretty quick so we can head out. So these levels on these stairs, as you can see, this area is flat. This area is flat so that the guys can work on the azimuth bearing, sometimes referred to as the hydrostatic bearing. You can see it here. It rotates over 360 degrees, basically sitting on 10,000ths thick layer of oil. You might be able to hear some of the pumps running. The antenna is not ready to rotate yet or change elevation. They're working on that. They've delayed a lot of that work to get us ready to make RF power. Sorry, you can hear me breathing a little hard. This is some more of the countryside. We're going to go up these steps now. We're going to go to the pump room. sometimes referred to as the alidade level, or as the Australians call most storage buildings, a caravan. Whew. I'm out of breath. So inside this caravan, it's about a 40-foot container. This is the pump stand as it was in at Continental. Everything's working great. This is somewhat of a copy of the 1,000-gallon tank that we had at Continental. It was fabricated here in Australia. This entire building was taken down and refurbished and brought back up on top of the antenna. So there's the MCC, the heater controller, the PLC cabinet mounted there, and all the communications done between the pump stand and the controllers is all done with fiber optics. Shut this door. Alright, now I'm going to go up some more stairs. So we're about a third of the way up now. We get to do this about 5 or 6 times a day. You'd think I'd be in better shape by now. Give you guys a view of the countryside here one more time. It's very pretty out here. You can see in the distance the antenna directly in front of us is DSS43. The one to the right there is 35 and 34. 35 and 36 both have Continental 20 kilowatt transmitters in them. This is the elevation motor here. This is what tilts the antenna 89 degrees. It basically sits at stow at 1 degree. It's not perfectly straight up and down. And those are the teeth that move the elevation bearing, which I'll show you up here at the top. So I'm gonna have to put you in my pocket for a second and climb these stairs so I can be safe. Hang on. Okay, now that we're up here, some more elevation to see the countryside here. It's very pretty here. You can see the underneath side of the antenna structure now. This is the elevation bearing. That's probably about 3.5 feet in diameter. This is the visitor center over here that you're looking at now. So now I've got to go up a vertical ladder. So it's up this way, and I'm going to put you in my pocket again. Alright, so now I'm going to walk through this way. And what we're going to do is we're going to walk into what we call Mod 0, which is the first level of where all the transmitter equipment is located. These are the pipes that come from just below to cool the transmitter. I just hit my head, that's why you wear a hard hat. Going up another vertical ladder. So this is the new microwave pump skid. This is provided by JPL. We provide the manifold for our transmitter for it. These pipes over here is the facility cooling as well. So now I got to go up Another short vertical ladder. Now I'm in mod 1. And I'm going to treat you guys to something that not many people get to do. We are now out on this surface. Pictures and video don't really do this justice, but I'm going to walk out here to where the mesh screen is, and then I'll turn around and describe the other levels of the antenna. You can tell I'm breathing hard now. So down there where the door that I just came out of is mod 1. This one right there. This level here is mod 2, mod 3, and then you can see the dancing Roland up there in what we call the XTR cone. The cone to the left of Roland is the S-band cone, and the cone on the backside is what they call the host country cone. So inside mod 2 here is where the S-band transmitter and the manifolds are located. Mod 3, this level here, makes it look small when my finger's out there. Mod 3 is where the X-band control cabinet is located, and then where Roland is located, and where we're going to finish this video is where the X-band tube is located in final power amplifier stage. So this is a really cool place to be when it's pretty outside. Some really pretty views. When it gets hot out here, the surface reflects a lot of heat and it gets really hot. So even while we were here, I got hot working up inside the cone because the sun would reflect up and get you sweating. So we're gonna go back in, and then we'll meet up with Jason and Eric, where they'll kind of give you a quick rundown of mod 2. All right, I'm gonna have to put you in my pocket again. Okay, so here's Jason, and we're gonna walk you through mod 2. So this room is about 28 feet in diameter. And then at this point in time, it's got about 90% of Continental equipment located in it. You want to say anything?
Okay. So on the business end of things here, we've got the hot loop manifold that's pumping up 45 degrees C water for the X-band klystron that we'll be seeing in just a few minutes. That's 2 full floors above us. We've got the cold loop manifold, and that's actually providing water for both the X-band, previously mentioned, and the S-band. And since this is the biggest mod on the cap, we've also got the largest single piece of equipment here besides the transmitter, and that's the S-band PA cabinet. So you can see all of the plumbing coming from the manifolds and the control cabinet. And this includes the 100 kilowatt klystron in the PA cabinet. Got a control cabinet, and the final piece is the S-band hot loop manifold, providing the cooling for the 100 kilowatt klystron.
All right, so we need to hurry up and leave the antenna, so we're going to go up another vertical ladder, and we're going to go up to mod 3. It's up there, so hang on just a second. Another pocket traveler. So here we have Eric.
Welcome to mod 3.
Or now he's now been nicknamed Eric. I don't know if he's even noticed that. Can you turn your hat, take your hat off and look at the front of it? So we all had nicknames so that we'd know each other on the radios. Mine is LFA. Eric didn't like his original nickname, and he didn't want to give himself one, so I gave it to him, so we called it Eric, since he likes to try to air out rocks and frisbees. Jason's nickname was Burgundy, for Ron Burgundy, and then Roland is Ninja, because he says he's a ninja. So anyway, we're in Mod 3. Do you want to say anything, Eric? Do you want to walk around, or you want to hold the camera?
Follow me.
Okay, we're going to follow Eric over here.
Mod 3.
So just real quick, Mod 3 is basically the same size and scale as Mod 2, which is 28 feet in diameter. We don't have a lot of Continental equipment in here, but we do have what Eric's about to tell you about.
Yeah, we have the X-band control cabinet, just like you saw down in Mod 2. You saw the S-band control cabinet, basically the same, except this one actually has a magnet power supply in it. Isn't that right, Jeff?
That's correct. So yeah, they're almost identical cabinets. A few minor changes, like Eric said, with a magnet power supply, which is good. We like to keep as many consistent parts as possible, so we can almost just copy each cabinet. So you want to show them the front of the cabinet, or?
Yeah. So here's the front of the cabinet. There's about, maybe 4 feet of space between that and the wall. There's our GUI. You can see there, X-band control cabinet.
All right, thanks, Eric. So just as we walk around, that's a heating and air conditioning duct. That's the S-band waveguide switch, one of them. And then we're going to walk over here. This is where most of the antenna controls, RF interlocks, antenna system interlocks. This is the CCG interlocks, and low noise amplifiers are stored, and exciters. So this is Eric's going to stand next to the harmonic filter for the S-band, just to kind of give you an idea of scale. But just to let you know, that was downstairs in Mod 2. They had to lift that up here. It's extremely heavy. I don't remember the weight, but it required a crane to move it outside what we call the patio doors, which are these doors here with the chains across them. Lifted them out onto the antenna area and then back into the lower level doors. So that's about it. Just a real quick note. Just virtually every one of these antenna levels was gutted and redone. So pretty much everything you see on the walls was probably here before. Then it was removed, reinstalled. This whole entire floor was refurbished. Holes were welded up in the floor. New material put down just to accommodate our new transmitter. So I'm going to go up to the cone level now, where we'll let the Ninja, Roland Liu, kind of give y'all a brief description. So he's up high. So let me hand this to him, up yet another vertical ladder. Here you go, and then I'll come up and I'll... Alright, so we're going to just add to the last video. So there's Roland. And
Thank you. This time I'll make sure I hold it to the right place. So right now it's about 5 o'clock, and that's the sun. And the sun is in the direction, just so happened to be the antenna tilt directly to my back. So it won't be able to see much because we are standing right between the two cones, which is difficult to see. Where I stand right now is about 40 meters above the ground. And so that's about 130 feet. And as you can see, as you see, we have all the equipment on the same floor, but now we basically break it down into about 6 different levels. And you can imagine how difficult that it is in terms of integration. Here's the X-band Klystron.
I'll hold it so
Okay.
you can go in and... Whoops.
Yeah.
All right.
So here's the X-band Klystron. Some of you may see the big red Klystron in your facility for a couple of months. And basically we pack it all up and ship it over here. And here's the power supply, filament power supply with the enclosure. Since the power supply is at voltage, we want to make sure that nobody can touch it. And the power from the klystron basically will go up on the front, that little red thing, going through the RFOA, go to the feed, and then radiate to the top. So if Jeff can tilt, you can see a big round thing on the top. That is the sub-reflector. And basically the power will be on the sub-reflector and then reflected back to the dish where Jeff was before, and that dish is about 70 meters in diameter. So it's a huge dish, and then all the radiation will be collimated and then basically sent into the space. The S-band will reach Voyager at 2 gigahertz. This X-band will reach like Mars and rover, so that would be a 2 different frequency. So I want to thank everybody at CEC. So we took this antenna down in March, and of course the transmitter was built for a couple of years, and start from the NRE design phase, and we got all the drawing done, all the design done, and start manufacturing. We took it down in January, put it on the 2 40-foot container and sent it over here. We start integrating. The antenna was down starting March, and that was the last time that we communicate to Voyager. So in October, that we will talk to them again, talk to the Voyager again. So I want you to all know that you are part of this success story when we are able to communicate to Voyager again. And on behalf of JPL, DSN, and NASA, I want to say thank you very much. And good job.
All right, thank you, Roland. So anyway, we'll just end this with a quick view of a little bit of a sunset there. Like I said earlier, it's beautiful out here. So you guys take care. Hope to see y'all soon. Hope everything's okay at home. Y'all take care.